In Chapter 5, we're going to start looking at derivatives and integrals of functions that we haven't taken the derivative integral of yet. The first one is the natural log, so ln, which you should always remember is actually log with a base of e. Okay? So I've got the rules up here. The derivative of the natural log, or ln, is 1 over x. Okay, and x has to be greater than 0 because we can't take the log of anything that's less than 0. Because if we think of it this way, we've got log base e of some number. Okay, let's say it's e squared to make it easy. Or actually, we'll look at just a real basic one. Let's say we had log base 5 of x. Okay, what that means is whatever this equals, that's the power that we'd have to put on 5 to make x. So if this equaled 2, I could rewrite this as 5 squared equals x. So x would have to be 25. Now, if you think about it, we can't possibly have any number in here that's less than 0. We can't have 0 in there either because 5 to a power will always be some positive number. So the different types of numbers we could have out here, or in our exponents, would be whole numbers, which are going to increase the value of 5. We'd have negative values. If I put a negative 2 in here, 5 to the negative 2 is 1 over 25, which is still a positive number. And we could also have fractions in here. Okay, so 5 to the 1/2. Well, that's the square root of 5, which is positive still. So it's impossible to take the logarithm with any base of anything that's less than or equal to 0. So that's why we have this limiting factor on our domain. Same thing if we have u. Okay, so if this wasn't just an x, if this was some other function inside, we would do 1 over whatever that is, and then we would multiply this by the derivative of u. Okay, so basically this is setting up our chain rule. So I've set up some examples here that we can use just to get you familiarized and kind of reacquainted with derivatives also, since we've been doing integrals for a while. Let's say I have this function. I want to know what f prime of x is. Okay, well, remember that we've got to look at the outermost function. So the outsidemost thing is ln. So I'm going to take the derivative of ln. So we could think of this as ln of u, where u would be 2x squared plus 1. So the derivative of ln of u is 1 over u, according to our rule from up here. So I'm going to do 1 over my u, which is 2x squared plus 1. And then I need to multiply this by the derivative of u. So the derivative of this, which is our inside part, so this is chain rule, would be 4x. So my answer would be 4x over 2x squared plus 1 dx. Okay, and this couldn't be simplified at all. You can't cancel terms, and this doesn't factor, so we'll just leave it like this. Next example. Here I've got two things multiplied together, so this is going to require a product rule. So remember, the product rule is derivative of the first times the second plus the first times derivative of the second. Well, the derivative of ln of x is 1 over x. So 1 times ln of x is ln x plus x times 1 over x is 1. And this would be our derivative. This next one we could do as a chain rule, kind of a double chain rule. So if we go through it that way, it would be 1 over the inside part, which is the square root of x squared minus 4. times derivative of this. Okay, so derivative of this would be 1/2 the inside part to the negative 1/2. So we drop our power by 1 times the derivative of inside part again, which would be 2x. And then we'd have to do some simplifying. But I want to show you another way that we can use our properties of logarithms to make this a little bit simpler. What we have here is ln of x squared minus 4 to the 1/2 power. Now, if you remember, logarithm properties allows me to take my exponent and bring it down to the front here. So I've got 1/2 ln of x squared minus 4. And that's the same thing. And now what I can do is I could factor this. So it could be x minus 2, x plus 2. And then since I've got multiplication, I can split these up and give them their own logarithm. I'll keep putting it underneath here. So I've got 1/2 the ln. Okay, and that 1/2 is going to go to all my ln's, but the first one here is going to be x minus 2. And then since this multiplication turns to addition, so I'm going to have the 1/2 in front of this one also, ln x plus 2. And now, when I take the derivative of this, it's going to be a simpler derivative because I'm just going to have 1/2. Okay, the derivative of ln is 1 over, so it's going to be 1 over the inside part times derivative of the inside, which is just 1. So I've got 1 over 2, parentheses x minus 2, plus the derivative of this guy, which would be 1 over 2x plus 2. And this would be my derivative, which looks a lot different from this, and this would take a lot of simplifying to get it to equal something that's simpler than this, or something that's as simple as this. So you want to take advantage of your logarithm properties when you're taking derivatives to get a simplified answer. And here I would have to say that x cannot equal 2 or negative 2. And actually from up here, if we're looking at domain, I can't have it equal this because that would make the inside part 0. And I can't have it be anything that's going to make this negative either, so it would have to be in between these numbers. So really x would have to be between negative 2 and 2. And that would be my real domain. Okay, because remember the domain of your original function affects the domain of your derivative also. Let's look at another one, kind of same concept. We're going to want to expand this because otherwise I'm going to have a pretty nasty looking quotient rule inside of a chain rule. So let's expand this out if we can. This is really a 1/3 power, so that's going to come down in front. So I've got 1/3 the ln of x minus 1 over x plus 1. If I expand this, division turns subtraction. So 1/3 ln of the top minus the ln of the bottom. Then I can distribute the 1/3. And now I can take the derivative, and it's going to be a lot easier than taking this big complex derivative. So 1/3 times the derivative of ln of x minus 1, which is 1 over x minus 1, times the derivative of x minus 1, which is just 1, minus 1 over 3 times x plus 1. Okay, and this would be my derivative of this. So again, properties of logarithms make problems a lot easier. Let's see how we can apply properties of logarithms to a problem that doesn't initially have a logarithm in it. So here, this would be a big chain rule, and inside that would be multiple product rules. So I'm going to use my ln rule, my logarithm rules, to make this easier. And what I can do is I can take the natural log of both sides. Okay, and now I'm allowed to use my logarithm properties. Okay, because the natural log is just function like anything else. Okay, so I can take the natural log of both sides, just like I can multiply both sides by 5 or add 2 to both sides or anything like that. It's just another function that we're allowed to do as long as you do it on both sides of the equation. Well, this turns into 1 over y times y prime. And this becomes, let's see, this would turn to a 1/2. So let's just expand this first. It's going to be 1/2 ln, and then we have products, so those are going to turn into addition. So x minus 1 plus 1/2 ln of x minus 2 plus 1/2 the ln of x minus 3. When I take the derivative of this, I'm going to have 1 over 2x minus 1 plus 1 over 2x minus 2 plus 1 over 2x minus 3. Okay, and then what I'm going to want to do is substitute what y was back in here and multiply on the other side. So what I'm doing is multiplying both sides by y, because I need to know what the derivative is. I need to know what y prime is. So I'm going to multiply both sides by y, which cancels this. And this is times y, but y is really this thing. So I get this, and then I would distribute that in to all of them. So I have 1, well, not 1 anymore, it's going to be the square root of x minus 1, x minus 2, x minus 3 over 2x minus 1 plus, let's see if I can copy this thing. This is 2x minus 2 and 2x minus 3. Okay, so I have this, and then I can do some simplifying in here because really this square root can be applied to all of them. So we could make all these to the 1/2 power. And then this here would cancel this and leave this to the 1/2 power. This would cancel this one and leave the bottom to the 1/2, and this would cancel this one and leave that to the 1/2. So we could write it as x minus 2, x minus 3 under the square root over 2 squared x minus 1. And we could turn this to 4 underneath the square root, and then we can combine all these under 1 square root. This is just simplifying things. So we get the square root of x minus 2, x minus 3 over 4x minus 1. We do the same, similar thing here. X minus 1, x minus 3, 4, x minus 2, x minus 1, x minus 2 over 4x minus 3. Okay, so that's what y prime would equal. I don't really know which one is simpler. I guess you could keep it this way, or if you want to change it to this, it's kind of up to you. They're both usable. And those are just some of the things you can do with derivatives of natural logs. So that finishes the first part of chapter 5.